Hello, my name is German Cortez, and I'm here to explain my exam 2 code and my pseudocode. So to start, let's go over to my pseudocode, which is right here. So as you can see, originally I had the idea of creating 4 separate, basically user-defined functions, and I was going to store them under path.h. And then what I was going to do was have each one of the user-defined functions go. It was going to look up basically by doing an I++. It was going to look down by doing I minus minus. It was going to look right by doing J++, and then it was going to the left by doing J minus minus. Then it would start solving the maze algorithm, and I would define a maze array where I would actually store the maze itself. Then I was going to ask for user input, so I could put the entry point for I and J, basically the row and the column, and the exit point is the same thing, but it would be a K and L, which would be where Mario is actually located at. Then I was going to have a sum variable equals 0, so that every time that it would go through one of the iterations, it would continue adding and it would continue looking at it as part of the path. If it did not do it properly, then it would go to the next, and it would go row minus minus, so it would check up. What I found with this, one was that doing an external header file was going to be more complicated, and second, I learned that there's a recursive option that I could use instead. I went with that way. Also, after running a couple of tries, I did something similar to this, but I found myself going up and down at one point in time. So it was checking up, there was a space, then it would check down, it would go down to that space. So then I actually started working on my code, as you can see here, all 1 million lines of it. And basically I ended up creating a recursive user-defined function called path, and it takes integers a, b, x, y, and last step. This last step is very important because it's what keeps me from staying stuck in the loop. Basically, it tells me what my last step was. So if the step is equals 1, it basically tells me that it just came from the right, and then that means I will have to check left, up, and down. Because if I checked right, of course I would have a path, and it would move back to that path, and then I would end up in a loop. I would keep going left and right, or up and down in the same spot. So I have 1, 2, 3, and 4 up. The reason I did it with numbers, I ended up choosing an integer. When I was trying to use a string that was actually last step, it was giving me issues, and I couldn't clearly define left, right, up, and down. I was just having some issues itself. Also, I had to move the maze out to the global directory when I had it local, and then I was running my user-defined file. It was not being able to store to that memory location, so it was giving me issues. That's why I moved it out here. Then I have my I and J, of course. Now we go into our main. In here now, I'm going to declare my a, b, x, y, and last step. If you notice, I put last step equals 2, which if we look up here, 2 means that it was going down. So basically, I started everything as if I had just gone down into my array, into the top row of the of my maze. So that means it's gonna look left, right, and down again. It will not look up because then it would move back into the step where it was at before. Now over here, you're gonna see this is our entrance row, entrance column, exit row, exit column. And basically I'm gonna do a user input in order to tell it what the row is. Here you see the file pointer. I open the maze.txt that was provided to us. I read it, and then what I end up doing down here, I actually take everything I just read, all 120 rows and 22 columns, and I store it into this array that's just called array. That one's gonna have everything all in one. And then what I do from there is actually quite interesting. I ended up creating a switch, and this switch is going to help me pick basically maze 1, maze 2, maze 3, maze 4, and so on. So in here, the very first one is very straightforward. It's just we're gonna go from 0 to 20, and J is gonna go up to 22. Actually, the columns are gonna go up to 22 on all of them because all the mazes have 22 columns. But on the first one, we went from 0 to 20, and we stored it into an array called maze, which is the one that the Pathfinder user-defined function is actually going to navigate. Later on, we did the same thing after we do the user input again. But if you notice, what allowed me to do that is I just took I minus 20. So I would subtract the last maze that I had just ran. And the next one is going to be I minus 40, I minus 60, I minus 80, and so on. So it's actually pretty straightforward. Once those values have been assigned to the maze, I actually start running my Pathfinder maze solver, which you're going to see it over here in a minute. But see here, entrance row, ER minus 1, it declares what our actual memory location is for the entrance row, entrance column, exit row, exit column. Now this is the beauty right here. So what it does, path is going to take A, B, X, Y, and last step. So the very first thing it checks, if A, which is my entrance, actually if my current location is equals to my exit, or basically where Mario is, it will be like, hey, success, you found the princess. The princess found Mario. This is the solution to the maze, starting at the exit and moving towards the entrance. The reason you see this is because when I started printing the steps as a recursive option function, it started printing from the deepest step. So it actually started printing at the very end, and then it moved all the way back, so it looks backwards. But it was actually solved the correct way. I just couldn't figure out how to make it print the way I want it. So the first thing it checks, if last step not equals 3, so basically if the last step was not a left, then check the right, if that makes any sense. So it's gonna add 1 to the column, it's gonna check, and if it is equal 0, it's gonna take a step there, and it's gonna print our current location. And then it's going to print out solution to the maze, and it's going to return a 1, which is like, yeah, that happened. Otherwise, it's going to say, hey, can't turn right, and then it's going to check 4, which is actually checking down. If the last step wasn't if there is a path, go down, and then it's going to check, okay, if the last move was not a right, check a left, and so on. And basically it continues doing that, and that's it. Basically it checks if your last step was not down, check left, right, and up. If your last step was up, check left, right, and down. If your last step was not a left, check right, up, and down, and so on. Then whenever we run it, it's actually pretty neat. It runs, it asks you, hey, which maze would you like to use? Eventually, once the computer catches up, and let's say I would like to use maze 1. It shows you what the maze looks like. It asks you, hey, enter the row number from 1 to 20 only. Row 1, column 10, and then we're gonna go to row 20, column 13. Boom, there's our option. So it goes from 110 to 210, 310, and so on, all the way to the final step, to 2013. This is the solution to the maze, starting at the exit and moving towards the entrance. But this is the actual logic that it went through. So it started at 110, so it was like, hey, can't move right, take a step down. Can't move right, take another step down. Can't move right, take another step down. Can't move right, take another step down. And it continued doing that. Then it was like, hey, I'm able to go to the right. It went that way, and it continued doing so. And then whenever it couldn't do anything else, it actually it doesn't show it on this one, but it will take a step back, and it will say, hey, took a step back. Well, that's everything. If you have any questions, please let me know. Thank you.